Alright everyone, so welcome to the second part of your video on two-step percentage problems. This is going to be part 2. In the first part of the video, we covered two-step problems where you're increasing and increasing twice over, and where you are decreasing and decreasing twice over. Now, we're going to do examples where we increase then decrease, or decrease and increase, so we're mixing and matching, okay? Let's do the first one. A store buys phones on sale. Sale. That means, oh, it's cheaper, for $150. Okay, so it buys them cheap, but then it goes ahead and it marks up the price by 20%. Yeah? It's marking up the price. It's increasing the price by 20%. Now, the store, after a little while, the store is like, it's not working so well for us. So the store then puts those phones back on sale for 30% off their normal price. What is this new sale price? Yeah? So please notice I've already started splitting this problem up into two parts. So part 1 is the yellow part, and part 2 is the orange part, okay? So in the first part, the store is like, yo, I'm buying these phones for $150 and I'm increasing their price by 20%, yeah? And in the second part, the store is like, nah, I gotta drop their price again. So in the second part, you are decreasing their price by 30%. Okay, this is pretty straightforward. Let's go ahead and let's solve it. So, first of all, my original amount always as a percentage is 100%. So, when I do 100% plus 20% for that markup of 20%, the store is now charging 120% of what it bought the phones for. So I'm looking for 120% of 150. Well, I'm going to turn that percentage to a decimal. I'm going to move the decimal point over 2 spots to the left. That's 1.20 of is times 150. Yeah? So, pulling up that calculator, my best friend, 1.20 times 150 is 180. The store is now selling these phones for $180. But that's the moment. That's the end of part 1. And the store is like, these phones, they're not selling. People don't want them. So the phones, we have to put them on sale. So the store takes that $180 phone that it has and it advertises to the customer, hey, we have a sale today. So it decreases the amount that they're worth by 30%. Now, as always, the original amount is 100%. Yeah? So 100 minus 30, the store is now charging 70% of what it put these phones up to be sold for. So 70% of 180. That's what we're looking for now. We're going to take 70%, make the percentage into a decimal. This becomes 0.70 times 180. Okay, so we're going to put up the calculator one last time, and that's going to be 0.70 times 180. Voila. The store, the answer is 126. The store is now selling the product at $126. That's our final answer. By the way, some of you might have noticed, Mr. Pearson, but what does this mean? It's selling it even cheaper than what it bought it. Yes, it is, but sometimes when a store can't get a product to sell at all, it's better to accept a loss of a little bit of money than not to sell, and then you lose all the money that you invested. So sometimes this actually does happen in real life. Okay, let's move on to the second and final example of this video. Decrease then increase, yeah? Frank bought a jacket for $25. He has a coupon for 10% off the price. Coupon means I'm subtracting. That's a sale, kind of. Okay, so Frank deducts the amount, but then, when he's going to pay, he has to go ahead and add a 7% tax to the original amount of the bill. How much does Frank pay to the nearest cent? Now, this is a tricky one, okay? So, as always, 2 steps. Part 1, yellow. Part 2, we're going to mark in orange, okay? So, in part 1, Frank wants to buy a jacket, and the jacket costs $25, yeah? He has a coupon that's going to take 10% of that off, yeah? So my original amount, always, as a percent, is 100%. So we're doing 100 minus 10% gives me 90%. Frank is now only paying 90% of those $25. So, okay, we're going to go ahead and we're going to take the decimal point, move it 1, 2 spots to the left. This becomes 0.90 times 25. Okay, calling on calculator assistance. 0.90 times 25 equals 22.5. So Frank would pay $22.50. Yeah, $22.50. That's the end of part 1. However, after Frank takes that amount of money off because of the coupon, Frank has to pay a 7% tax on the original amount of the bill. Now the key word here is original. The original amount was $25. So in this particular case, because we read the problem carefully, we understand, yo, my original amount here is $25. So I want to find my 7% tax. Okay, so if my original amount, again, is 25, I want to find what my 7% tax of 25 is. So I'm going to take 25, and I'm trying to find 7% of 25. I'm going to move this decimal point 2 steps over to the left. That gives me 0.07 times 25. And using my calculator again, just to save time, that's 0.07 times 25. Aha, $1.75. $1. Ooh, I'm sorry, I miswrote that. $1.75. But, as I'm sure you've noticed, we're not done yet. We basically found out how much money Frank is going to end up paying for the jacket. Yeah, $22.50. And we found out how much tax Frank is going to pay on the jacket, but we're trying to find out how much Frank pays in total. We want to find out how much he pays in total. So the last and final step, yep, this one's special. It's a 3-part problem. The last and final step is we have to add these together, okay? So for the jacket, he paid $22.50, and then in tax, he paid $1.75. So we add them together, yeah? 5. Voila. Once we add them together, we find out that all in all, Frank paid for, with the coupon and then adding tax to the original amount, Frank went ahead and he paid $24.25. And that, ladies and gentlemen, is my final answer. These are complicated, I know, but as long as you read the question thoroughly, it isn't too difficult. You just have to do 2 different sets of work. Keep your notes organized, keep yourself organized when you're working this out. It shouldn't give you too many issues.